In our last video, we defined the average rate of change as the slope of the secant line between 2 points. Today we will learn about rates of change in linear and quadratic functions. A linear function is represented graphically by a straight line, and one of the key characteristics of a linear function is its constant rate of change. This means no matter which 2 points you pick on the line, the steepness between them never fluctuates. This constant rate of change is called the slope. Let's represent this same graph using a table. To identify the rate of change, we calculate the first differences. So 2 minus 0 is 2, 4 minus 2 is again 2, 6 minus 4 is 2, and so on. Since these differences are constant, it tells us that we have a linear function with a constant rate of change of 2. If we try to find the second difference, we will always get a 0. This shows that the average rate of change stays constant.
In other words, the rate of change for a linear function is constant, but the rate of change of the average rate of change is 0.
We can also use the change in y over change in x formula to find the rate of change. Now let's take a look at this table, which represents a quadratic function. If we calculate the first differences, you'll notice that the values are not the same. Each step gives a different change, so the function isn't just growing, it's speeding up. The rate of change itself is changing. And we can evaluate that change of average rate of change by finding the second difference. You'll notice that the second differences are all the same. This tells us that the function is quadratic.
And here, the rate of change of the average rate of change is constant.
The second difference also tells us about the shape of the graph. If the second differences are positive, the graph is concave up. And if they are negative, the graph is concave down. If a quadratic expression is given, then we can also determine the value of the second difference by using the formula 2a, where a is the coefficient of x squared.